all are for database management. So he has demonstrated for SEL relay. So let us take the SEL relay. So 787 model number. So here, uh, what he has did the calculation in all manufacturer software, you will find the relay library. So I will show you in two different software. So here, you just click here. So SEL has three differential models. So anyone, this is the available for demo tomorrow. So I will select this one. Write anything here. So I just written the code. Next. So this is generated from the default value. Okay. So here you have to put the rating of transformer. He has a 25 MVA, right? So it is 25 MVA. So generally CT connected in the star connection. So we will not change it. So winding one is a star or delta. Whatever is there, you can select. So CT ratio, so 600 or whatever. I am just putting it. Whatever in your system, you have to select that. If winding two, I will put here 0 and KB just geometry. So right now I am interested in drawing the characteristic. So characteristic is drawn from the settings, which is here, what he has shown. So all other details as per your transformer, you have to put here. So it will automatically calculate everything. So suppose here it is 1600 or whatever, you have to. Winding to CT, it is a star. If the second winding is a star, then you have to select a star. Otherwise, if it is anything else, then you can select from here. Yeah, it is a yes, actually yes. So vector group you have to put here. If delta it is vector group 11, then you have to select 11 or whatever. Okay. So all the these settings is according to the relay template. When you open the SEL relay software, everything will be the same name. So you will not be confused where we have to enter what. You just open the software and whatever setting is there with same name, that will be there. Put the same setting, whatever in the. So once you put all these things, so here is the setting for the characteristic creation. So it was a 0.3. Just check it. First slope was 30%. Second slope was 100%. Okay. IRS1 was 1.5, I think. 1.5. This one was 12. Correct. So these are the harmonic restraint setting. It is not required here. So if you have that setting also, you can enter. So just click. This is the characteristic already generated. You can see in the table format. You just click here. So it is here. Now what he has calculated, you can see from here. It is is exactly same. You match it. It is differential. It is I bias. It is x-axis.
Mr. Uttap,
Yeah.
what is that? Like,
Yeah, it is just line angle. It is you need not to confuse with this. It is just line angle. You have to. You can see that there is only two slope here.
yeah.
Huh? But he has drawn three slope because it is just a line, and if we close here, the table will be like this. If we close there and see here, there are three slope because this pickup sector ID1, so that cut the that first slope, so it is converted in three. Otherwise, actually, two slope is there because we limit the pickup current. So that is why this pickup current cut the first slope. So there will be three segment there. Understood? So here you can match exactly same what you have calculated, 100% same, right?
Yes.
So the first point was 0. 0 means here 0, 0. If you can write here 0 to 0.3, then it will be same. Now it is converted this because this point 3 is taken from here. That is why it is not showing. If you are right here 0.3, then it will be exactly same. There will not be any difference in characteristic. Okay. So all other point are exactly same what you have calculated, right? So for any characteristic, you just need to select the relay template if you do not want to calculate. But you should understand how we calculate the characteristic. That is why that part was very important to learn. So now, if we have, we do not have time during testing. We do not have time to calculate each and everything. So better we should use the library what is available and do the testing quickly. So now if there is any other setting other than this, then we have to calculate again. But in this case, in template, if you will put all the setting as in relay, then characteristic will be automatically created. So once it is created, you just close it. Here also you can see the formula will be also defined automatically. You need not to select. Whatever relay you will select, based on that formula automatically will be selected. Okay. So it will be quite easy. And suppose you want to test the ABB relay, as I was saying here. So I have selected SEL relay. That is why when I will select here, then only SEL relay is there. But there is option here you can select. All the relays will be here. So let us select the ABB relay this time. RET 670. I will write ABB. This is also same. Here name is different. It is according to the ABB relay name, so that the user will not be confused with the new settings. So whatever in the ABB relay, the same name will be here. Okay. So here also let us select CT ratio and whatever is there. I will select the same. So maybe here I can change it to 33, and CT ratio can change same way as it is. You have to keep whatever in the relay. Otherwise, everything will be different. The test will be different because the current injection will be according to the your setting. Although characteristic will be same, but the current injection and all calculation will be based on the MBA rating and current. Okay. template is rated correct, 1500 something. I just putting it. I am not doing it. Okay. So this is the setting you have to put as per the ABB setting, with which we create this characteristic. So in section 2, yeah, it is a unrestrained setting, so it is 10. If you want to see other graph clearly, then if you reduce this, then it will be bigger one. It is 6 now. So whatever setting you have to put it, you need not to change anything. So if we go to the test again, now see again. Here the formula is max. Now like you can see
Yeah, yeah.
the for ABB max formula is
Okay.
so in template everything will be calculated automatically. So here also you can see if you follow the same what Anamala explained. So in this case also, in this case also you will find the same calculation as he explained. So for any relay, the calculation will be the same, the characteristic calculation. So the slope calculation, all things will be same. So in this way, here also you can see the only two slope is there. If you change it to 0.3, then again it is either you are entering or not. It is taking from here the pickup setting. So it will be when you going to test that in template, then the it will be 3 slope. Okay. Now once it is created, then you just need to uh, create test plan for testing. Here you have to select it. For a CL I have written a 87 name. You just need to select this one, and test point you can select anywhere. Complete characteristic you can test. Yeah, unrestrained characteristic can also be checked. Now suppose you want to test for all fault, you should select all. Otherwise for three phase, I am just going to demonstrate. In this software there is option for training. I am putting it in a simulation mode. Now if you run, uh, this is the way you will test. When you have connected the instrument to your relay and created this test plan, this is the way it will test. So it is in simulation mode. It will consider everything true. So it is testing that way. Those two. So at different point, it is testing the this is non-operating operating region. So this is the border point to which it is calculating. So similarly, I will show in one more software the differential, same calculation, same thing. Everyone is calculating same way. concept, any test kit you can use for testing. Even whatever he has explained, you can use that, and even without template, manually you can test all these things. So if you know the concept, that is more important. Okay, it is just running. So what is the difference between this point and this point? This is unrestrained region. Unrestrained means why we have this slope. This slope is for due to errors. When the current increases, then error increases. Up to the full load current, error is less. That is why slope is less. When we go to the higher current, like a through fault condition, then error will be more. So that is why the slope is higher at the higher current, through fault current. So in unrestrained region, what is the meaning of this? Unrestrained means it is this differential current is restraining. According to it, it is looking at the suppose restrained current is 8 here. So if differential current is less than this, then it will not operate. But once it reach here more than 12, if I bias is more than 12, then what will happen? So I differential, sorry, it is almost same. That is why it is. So if differential current is more than 12, so it will not look for bias current. In that case, it will immediately trip. So that is the difference between these. Okay.
Just now you said like the 6 point exactly on the line. But now you can see the three upper points shifted a bit wide.
Yeah, yeah, it will be slightly higher. It will be above. So it should be in limit because it is unrestrained region. So it should be above always. It is no operating region. So it will be the error is slightly higher in that case, unrestrained case. So and by the way, it is simulation mode. It is just taking as per algorithm. But when you will test actually, so it should be somewhere here itself, slightly above, and maybe at the same point. It is in simulation mode, so anything, any value will be there. Okay. So similarly, suppose you have another software. I'm just randomly explaining other. So any so that whenever you are testing, you can have any test set, any software, you can do that. And even if you follow his guidelines, you can do the manually also. Here in differential library, suppose SEL, same relay, 787. Okay. Here, I'm just interested right now in characteristic. So all values you can put whatever the actual relay have. Here, the this value was 0.3. First slope was 30%. Second slope was 100%. This was so I think there is some error in this template. So actually it should be it has limit the slope to 0.9, but it should not be. That is why values may be different. It is is not taking any. They have limit the this one to the 90%, but it should be more than 100%. Whatever anyone can, even we put the for generator protection, we put a 150%. So it is not correct. So values will may not match. So here, but if you put the same value in the other template, then it will be same. So it is a template here. Okay. So here you can see all the characteristic drawn here. Same way. So this value will be different because their template is not correct. If we put 100% and it has accepted, then you can see this point is exactly same what we calculated 1 and point 3. This is also same, this one, because 1.5 0.45. So this will not be correct because uh, they have used 90%. Okay. So any template you can use and compare whatever he explained, it will be same. And if it is not same, then there is a problem in the template. So there should not be any problem if you are doing the calculation. Because anyone has made this template, he may sometimes technical people explain that you have to this way, and developer do some mistake. Like in this case, they have limit the till the 90%. So always that is why in the previous software that Annamalai explained, it do not have template actually. In US, many people want to test their self. Suppose I have this template and I do not know how to create this manually, then I will stuck there. So template is not working. How I can test this? So that is why you should learn how to test it manually. So even I can create this. Now I know I have that table. I can create it myself. Even template is not there. So that is the difference. So here, if you once you add this template, so once you put all the values, then you can. It is running somewhere. I think in background. That is why. So so in Siemens relay also the same formula is used whatever is in SEL. So let us take in this relay. This is 0.3. So it might be according to the Siemens relay template, but here also he has limited, might be not there. So in all template they have limited the 90%. So that is why it is not a. So in all template there is a problem. Generally, mostly it is put the slope, first slope 20-30%, and the second slope 80-90%. That is why they have put. But as you are testing in your case 100%, so you may not use these templates. So if it is there, that is why it is very important to learn manual things also, so that even though it is not working, you can do the testing also.
Means if slope 2 is 100%,
Mm.
I cannot use this software to test
Yes,
everything.
it template, not template. You can test the
Still can
this
test.
template is wrong, not the software. From software you can do like here also. Suppose you do not have a software, then also how you can do a calculation you already have. Let us create manually. So I'm not selecting relay template now. Just go to next. So this is template. So what is the I here I will select the from manual. See what is the formula we are using in this relay. So all manufacturer formula is here. So we are using this one for, but not two. Here one. Okay. And here the pickup setting is 0.3. Here we will put 0.3. Okay. So here I have calculated for I bias I differential as he explained. So just insert the all points what we calculated. So first was 0 and 0.3, right? Okay. Second point was
Zero
he
point
has calculated 1 and 0.3, right?
one, yes,
One I bias 1
1.3,
and
0.3,
0.3, and first was 0 slope, so it should be 0. Okay. Now
one,
the second point was
1.5,
1.5. Here you
zero
need
point,
not to calculate, it will calculate automatically if you put the slope. It is calculated.
okay,
Now the third point was
uh,
13.05.
0.5,
Here slope is 100%.
100,
Correct?
yes,
So the same thing is created. I have not used template right now, but it is not completed yet. It is just characteristic, which is difficult part you have done. All others you have to put the other settings also, like what is the rating of the CT primary, and all these things you have to enter. Otherwise, it will inject different current. So here I have to select three phase and CT primary. It might be 600 or whatever you have to put here. It was 1600. He has also calculated the compensation, right?
yes,
So ratio compensation is same. So I don't know what you have calculated. The same you put here that
matching factor is
matching
in
factor.
terms of,
So it will calculate the rated current
yes,
automatically. or you can enter the rated current, it will calculate it. So suppose you have calculated, I think 0.73 or something. Here, here you have to 0.73, right?
Yes.
So it will automatically calculate ratio compulses. One thing you have to enter here.
Okay.
So similarly here, I am just putting anything 0.84 or something. So whatever value is there, you have to put. And one thing he has not explained that is important in this to understand is this vector compensation he explained, but uh, uh, zero compensation, zero sequence current elimination. So that is a very important factor in differential relay. That that only factor is difficult to understand. So suppose it is a star transformer or a star delta transformer. So here vector compensation will not be like based on that star is there, then I will select YY0. It is not like this in this case. So if you do not have template and want to do this compensation, then you have to calculate, see the different relay has different internal compensation for zero sequence current. So zero sequence elimination require this compensation in our software also, so that it inject according to the relay requirement. So when we are putting in the template, you would have seen that when we have selected delta star connection and vector group, it automatically selected this, but not according to the actual vector group. It is actually internal compensation. So how you can calculate it? Just do the first, when you start first single phase trip, as you said that pickup test.
Yes.
So whatever you have told, that is valid for three phase. In three phase balance current,
Yes.
there is no zero sequence current. So it will be exactly same whatever the setting. But if it is a star winding and it is earthed, then the pickup current will be higher than that.
For delta.
Because suppose you are injecting 1 ampere, then what will happen? 1 and other two phases are 0 plus 0 plus 0 divided by 3.
Yes.
Zero sequence current is how much? 1 by 3. So that will relay will eliminate 1 by 3 ampere. So that is why it is higher than the pickup current required. So once you will calculate, inject and see how much current at which it is tripping at single phase, three phase will be same whatever setting. So you divide by three phase pickup. So there are four possibility. So I will explain detail in tomorrow's presentation. So depend on the ratio, you can connect the transformer in four way. So depend on this ratio, we give that compensation, this YY value. I will explain tomorrow.
Okay.
So it is done almost. So because theoretical part, if you will understand, then know how we compensate it. Okay. Hope it is clear how to test with the manually and using the different templates. Thank you.
Thank you, sir.
You can install this software for tomorrow's session.
of you have any doubts or questions?